Now let's look at a problem which illustrates another important aspect of thinking. And this is a problem set as follows. There's a basin and full of water, and floating on that basin is a tin tray, and resting in the middle of the tray is a bottle, beer bottle, wine bottle, milk bottle, also full of water. The whole thing's full of water. Now someone comes along and upsets the whole thing. So the bottle and the tray are all under the surface of the water. It's all upset, all on the surface of the water. Now, what I want you to think about, and you've got to think about carefully, is when it's all upset, what happens to this water level in the basin? Does it go up, does it go down, or does it stay the same? In other words, when the bottle and the tray is all upset and all goes into the basin, what happens to the water level? Go up, down, stay the same? How many people think it goes up? Okay. How many people think it stays the same? All right. And finally, how many people think the water would go down? Just one gentleman there. Well, actually, it goes down. Well, that's not surprising. I once gave this to a class of 30 youngsters, all of whom were gifted, IQs of over 140, and every single one of them got it wrong. Now, they didn't get it wrong because they were stupid or couldn't work it out. They got it wrong because they were thinking too fast. And one of the big problems in thinking is we zoom along and think too fast. So in this case, we say water floating, water underneath, can't make any difference, it's probably going to stay the same. What we need to do in thinking is really take it quite slowly, one bit at a time. For instance, what we say here is when they're floating, the water, the glass, and the tray are displacing water. It's the weight, the tray, the glass, the water, displacing water. When it's underneath, it's only the volume of the water, the glass, the tray displacing water. The water is the same in each case, but the volume of the glass and the tray displaces less weight than the weight, less water than the weight of the glass and the tray, which is because they're heavier than water, and that's why they sink. So if they're underneath, it actually goes down. So we need to keep in mind this thinking slowly, moment to moment, following it, rather than rushing ahead as fast as possible. Because outside emergencies, there's very few occasions when actually thinking fast makes a difference. And now we come to a very important point about thinking. Let's see how quickly we could find the tallest person in this room. Let's have some suggestions from you as to how we could find the tallest person in the room. Let's have suggestions. How might we find the tallest person?
Well, you could ask everybody, say somebody thought they were tall, then you could ask them, and
Yes.
then somebody could say if they were taller than them.
Okay, fair enough.
Make everybody stand up.
Make everyone stand up. Some others?
Ask everyone over 6 feet to stand up.
Okay. All right, I think the first suggestion is probably the best. Let's have those people who think they might possibly be the tallest tell us their height. Anyone who thinks he might possibly be the tallest? You do. How tall are you?
6'4".
Any advance on 6'4"? Any advance on 6'4"? Okay, you win. So that's a very simple way, a very nice way of doing it. All right, now, to some extent, you can't do much about being tall. There is a theory that the reason present generations are taller than older generations is that we use aluminium cooking pots, and aluminium is a trace element which is needed for making you tall, but that's only a theory. But essentially, you can't do anything about your height. But let's see something else about which you can do something, and I'm going to ask my assistant, Dinah, here to bring me 3 oranges with which I'm going to attempt to do something. Let's put these down. And what I'm going to attempt to do is to juggle. Obviously, not very good at it. All right, let's now get someone else to try and juggle. Dinah, you choose someone to try and juggle.
Would you like to have a go?
All right, have a go. Try and juggle. Let's see. That's better than I did. Try it. Okay, now let's see if there's anyone here who really can juggle. Any volunteers? Okay? All right, let's have the gentleman in the corner. Okay, now, the gentleman obviously can juggle very well. Now, let's just ask him, first of all, we'll ask him a question, then we'll come back to the general point. In order to keep your skill at juggling, how much do you have to practice, roughly?
Well, 3 or 4 times a week if I'm working on a routine.
Okay, now the distinction I want to make is between being tall, which is your genes, you can't do anything about, and juggling, which is a skill, which is a matter of practicing. Now, to my mind, perhaps the biggest fallacy ever in education is to believe that in thinking, it's just a matter of IQ, and if you have a high IQ, you are a good thinker. Now, why is this fallacy so dangerous, so very dangerous? And the reason it's dangerous is quite straightforward, and it's this, the 2 reasons. One is we believe that if you have a high IQ, then with regard to your thinking, nothing need be done, because you've got a pretty high IQ, you're probably a good thinker. If you have a lower or ordinary high IQ, it also follows that nothing can be done. So the result of that, to my mind, terrible fallacy is that we don't do anything about teaching thinking as a skill. And if we break away from that and we regard thinking as a skill, which I do, then we get a difference. Now, in fact, it's even worse than that, because in our experience, we've found that sometimes, not always by any means, sometimes people with high IQs actually turn out to be worse thinkers. And that's something we call the intelligence trap. And there are several aspects of it, and I'll just go through some of them. One of them is this, that if you have a high intelligence, you can take up any position on a subject and use your thinking to support that position. A nice argument, a nice rationalization to support that position. And the better able you are to do this with a fluent argument, the less you actually see any need to explore the subject. So you get locked into one particular view. Another aspect is that your status, your self-image, your peer image depends on being right, and therefore you won't open your mouth until you really are right. So you tend to be less creative, less provocative, less willing to explore. Another one is that you have a very fast mind, you take a little bit of information and immediately you jump to this conclusion. Someone with a slower mind may have to take in much more information and then finds it's something quite different. Another aspect of the intelligence trap is that you get more immediate achievement from proving someone else wrong, because that's immediate and it shows you're superior. So many of the best minds get into the mode of just using it to attack, to criticize, to prove something wrong. If we look at thinking as a skill, let's have some suggestions as to what we ought to do about a skill. Let's look at skills in other areas: cooking, riding a bicycle, driving, playing tennis, skiing. What do we have to do about skills in general? Let's have some suggestions. Someone sitting right in front, what do you have to do about skills?
You have to practice them.
You have to practice them. Another suggestion?
You have to read or in some way gather information about it.
Gather information about it. Something else? Over there, yes?
You've got to concentrate on it.
You've got to concentrate. I think the key thing is you've got to pay attention to it, practice, maybe test it, maybe pick out faults, but I would really say pay attention to it. So if we look at thinking as a skill, we ought to pay attention to it. We ought to perhaps look at it directly, rather than just say it should happen while we're doing other things.